Okay, now we'll discuss examples related to current and resistors. Example 27.1, it says that uh, a 12 gauge copper wire in a typical residential building has a cross-sectional area of 3.31 into 10 to the power minus 6 meter square. It carries a constant current of 10 ampere. What is the drift speed of the electron in the wire? Actually, we are to calculate drift speed in it. Assume each copper atom contributes one free electron to the current. The density of the copper wire is 8.92 grams per centimeter cube. So the given data is area, that is 3.31 into 10 to the power minus 6 meter square. It's given over here. Current 10 amps, which is again given over here. We are to find drift velocity. We know that charge on an electron is 1.6 into 10 to the power minus 19, though it's not given in the question, but we know these are the constant values. And mass of electron is 9.1 into 10 to the power minus 31 kilograms. So we are to find drift velocity. Uh, Again, the things which are also given in the question, that is the density of copper. The density of copper is 8.92 grams per centimeter cube. I'll convert this grams per centimeter cube into grams per meter cube. For doing that, this is the simple calculation, and in kilograms per meter cube, I have 8,920 kilograms per meter cube. Na is the Avogadro's number, which is 6.02 into 10 to the power 23, and m, the molecular mass of copper, is 63.5 grams per moles. I'll convert these grams per mole into kilograms per mole. So dividing it with 1000 gives me 0.0635 kilograms per mole. So this is the data which I'll use to calculate this drift velocity. This Avogadro's number and the molecular mass, it's not given, but we'll see that without these two things, we won't be able to calculate drift velocity. How? Let's see. To find drift velocity, we need to find small n. So to find the small n, we will proceed as we know that density is mass per unit volume. So volume is equal to mass over density. And from our previous knowledge, we know that number of molecules is equal to Avogadro's number per unit volume. So Avogadro's number into rho over m. So that is why we have written Avogadro's number in the data and the molecular mass in the data of copper to find small n. By putting this value over here, I get the number of this small n, that is 8.456 into 10 to the power 28. So now I have the number of molecules in copper, which will help me in finding drift velocity. We have calculated this drift velocity in the article. So I know that Vd is equal to I over NQA. I have the value of I, N, Q as well as A. So simply putting in all the values, and as a result I'll get Vd equals to 2.23 into 10 to the power minus 4 meters per second. So this is how we have calculated drift velocity for the given data in the question. In example 27.2, it is said that the radius of 22 gauge nichrome wire is 0.32 millimeters. So R is 0.32 mm. which obviously I'll convert into meters. In the data, you'll see that. In the A part, we have to calculate the resistance per unit length of the wire, that is R over L. And if the potential difference of 10 volts is maintained across a 1 meter length of the nichrome wire, what is the current in the wire? So in B part, we will be calculating I. So the data given is R equals to 0.32 mm after converting into meters, 0.32 into 10 to the power minus 3. R over L is to be calculated. Rho of nichrome is 1 into 10 to the power minus 6 ohm meter. Though it's not given in the data, but it's a constant value. So either a table or will be given in the question in case of quiz or sign or in papers. So if we want to find the area of the wire, we will simply use A equals to pi r square. R is given. Putting in the values, I get the value of A, which is equals to 0.321 into 10 to the power minus 6 meter square. Now I am interested in calculating R over L, that is R over L. So R over L is equal to rho over A. We have seen that R is equals to rho L over A. So taking this L over here, so R over L equals to rho over A. We have the value of rho, we have the value of area, so R over L will be equals to 3.11 ohms per meter. Now to find B, we have the potential difference 10 volts. The length is now 1 meter, and we are interested in calculating the current. So volts is 10 volts, length is 1 meter. We have to calculate R over L from part A. It is 3.1 ohms per meter, and the length is now 1 meter. So we can simply R over L into L, which will give me R equals to 3.1 ohms. Now we know that V is equals to IR. We have to find I. So V over R. V is 10 volts and R is 3.1. So the current will be 3.2 amperes. So this is a very simple example, and this is how we'll solve it. Now this is example 27.3. Here we have a coaxial cable are used extensively for cable television and other electronic applications. कोएक्सियल केबल होते हैं जो एक दूसरे के अंदर और जिनके एक्सिस जो है वो सेम होता है. So consist of two concentric cylindrical conductors. The region between the conductor is completely filled with polythene. अब एक this is one conductor and this is another conductor, and this region is completely filled with polythene plastic as shown in figure. This current leakage through the plastic in the radial direction is unwanted. The cable is designed to conduct current along its length, but that is not the current being considered here. Okay, the radius of the inner conductor which is given by A is 0.5 centimeter, and the radius of the outer conductor, that is this one P, is 1.75 centimeters, and the length is 15 centimeters. So this is 15 centimeters. The resistivity of plastic is 1 into 10 raised to the power 13 ohm meter. Calculate the resistance of the plastic between the two conductors. So we have to find the resistance of the plastic between between the conductors. So the data given was radius of the inner conductor, which is 0.5 centimeters. Let me check. Okay, and length is 15 centimeters. Radius of the outer conductor is 1.75 centimeter, and rho is 1 into 10 to the power 13 ohm meter, and we are to find this R. So how to find R is okay. This is how we can see the figure over here, and this is how we can see it. So the radius is given uh, from center to the plastic is R, and this is the thickness which is represented by dr. Thickness of the plastic is represented by dr, and the direction of the current is moving towards outside. So this is the direction of the current over here. So now we will find R. To calculate R, we will proceed as dr is equals to rho dr over A, and we know the value of A is 2 pi r L. For cylindrical shapes, the area is given as 2 pi r into L, that is radius of the cylinder into the length of the cylinder. So dr is equal to rho dr over 2 pi r L. Uh, when we will integrate this equation over here, we will integrate it from A to B, that is from the inner radius to the outer radius. So all of these I can take it out of the integral, that is rho 2 pi and L. So now I integrated putting the limit A to B, and I will proceed as rho over 2 pi L integral A to B dr over R. I know that integral dr over R is ln of R, and putting the limits, I can simply write rho over 2 pi L ln B over A. Now we have the value of B, we have the value of A, rho L. So simply putting the values, and I'll get the resistance to be equals to 1.33 into 10 raised to the power 13 ohms. So the resistance that the plastic is offering is 1.33 into 10 raised to the power 13. Now, in the question, we are asked to compare this resistance to that of the inner copper conductor of the cable along 15 centimeter. Formula which we will use is R equals to rho L over A. Area over here will be pi r square, that is because we are considering the inner conductor. So the area which we will use will be for circle, that is pi r square. Now putting in the values, the row will change because now we are considering copper. So the row of copper will be used here. The length will stay the same, but area will be pi r square. So putting in the values, I'll get 3.2 into 10 to the power minus 5 ohms. So it is very clear that when we have an insulator, the resistance is very high, but when we have a conductor, the value of resistance, it reduces remarkably. So these three problems are related to the article which we have discussed today. So hopefully it will help you in clarifying if you have any problem in the article discussed. Thank you.